Everyone, today we are gonna solve a very simple problem using DSU, right? So what the problem statement says is, in this problem, a tree is an undirected graph that is connected and has no cycles. Fine, okay. The given input is a graph that started as a tree with n nodes with distinct values 1 to n, right? So we are given a graph which contains n nodes, right? With one additional edge added. Okay, so this one is an important line. The graph is a tree. It has started with a tree and it has one additional edge added. It means that it will contain a cycle now. Fine. So this much part is clear. The added edge has two different vertices chosen from 1 to n. Okay. It may be 2 or 3. It may be 3 or 4. It will be basically between 1 to n. Fine. And was not an edge that already existed. Fine. Okay. The resultant graph is given as a 2D array of edges. Okay, so basically we are given this 2D array. Its name is edges. So what this 2D array represent is each element of edges is a pair u comma v with u less than v. Fine. That represents an undirected edge connecting nodes u and v. So basically अपने को 2D array में set of edges given होंगे 1, 2, 1, 3, 2, 3. What does they represent is there is an edge between 1, 2. Fine. There is an edge, and there is an edge between 1, 3. Okay. And there is an edge between 2, 3. 2 and 3, right? Okay. Return an edge that can be removed so that the resultant graph is a tree of n nodes. Fine. So basically what we need to do is we will return that edge which will constitute a cycle, right? So what the question demands from us is we need to return an edge that can be removed so that the resultant graph is a tree of n nodes. Right. So basically we need to return that edge which will constitute a cycle. Fine. If there are multiple answers, return the answer that occurs last in the given 2D array. Okay, fine. So there may be more than one edges which will constitute a cycle. So we will return that edge which occurs last in the given 2D array. Fine. So for example, if 2, 3 and 1, 4 are constituting a cycle, so we will return 1, 4 because it occurs after 2, 3, right? So what we will do is we are gonna apply DSU algorithm, DSU cycle detection algorithm. और इसकी वीडियो मैं पहले बना चुका हूँ. So I will simply implement it in this video. अगर वो वीडियो नहीं देखी तो पहले वीडियो देख के आओ साइकिल वाली, cycle detection using DSU. Okay. So what we are gonna do is we will traverse these edges one by one, and at each step what we will do is we will check whether this edge is constituting a cycle or not. Fine. So if this edge is constituting a cycle, we will save it in our answer. Okay. So what we need to return is it is an array. So we will return an array. Its size will be 2 obviously because an edge is always made by two vertices, right? What we will do is we will simply traverse this graph one by one and see which of these are constituting a cycle. At each step what we will do, we will see whether this edge is constituting a cycle or not. If it is constituting a cycle, we will save it in our answer, right? So one by one traverse करेंगे ग्राफ को और जो edge constitute कर रही है cycle वो save कर लेंगे अपन. Fine. So let me implement it. So I will make a class DSU. Okay. So suppose we are the number of vertices and P is the parent array. So constructor of this class DSU. Fine. Suppose X are the number of vertices, B is X, and what we will initialize this parent array as V. Fine. And we need to do some work on this parent array. I less than V I plus plus. We will initialize the parent array P of I as I. So this algorithm is already explained by me in different video. So I'm not going to explain everything. Right. So fine. अब क्या करना है मुझे? I will write a function unite public unite int x comma int y. Fine. What we need to do is int x superparent will be called get superparent of x, int y superparent will be called as get superparent of y. Fine. And we will just mark the parent of x superparent as y superparent. Fine. And when we will do this work, if the graph, if they are in a different component, fine, x superparent is not equal to y superparent, right? So one more function we need to define, public int get superparent, right? Suppose we have to find the superparent of x. So what is the base case? If x is the parent of itself, we will return simply this x, fine. And otherwise we will simply return parent of x as, this is the concept of path compression, get superparent. We will simply pass the parent, fine. So we have implemented this DSU class, and what we will do now is we will declare our answer array as its size will be 2, fine. Also we will declare the object of this DSU class, fine, and its size will be, इसका नाम चेंज कर देते हैं, e dot size, and we will traverse this 2D array one by one, right? I less than e dot length I plus plus. So what we will do is we will check, first of all we will save this edges in x and y. So x will be e of I comma 0, fine, and y will be e of I comma 1, fine. So one more thing, this graph is starting from 1 to n, but our DSU algorithm says that graph is starting from 0 to n. So what we will do is we will just decrement these by 1 and by minus minus, fine. And if g dot get superparent of x is not equals to g dot get superparent of y, we will just unite x and y, fine. Else what we need to do is, it means that cycle is there, right? So we will simply save our answers. Answer of 0 will be x plus 1. So basically मैंने ये 1 क्यों ऐड करा है यहाँ पे, क्योंकि इनिशियली मैंने x और y की वैल्यू एक एक कम कर दी थी। क्यों? क्योंकि DSU जो क्लास बनाई है वो कंसिडर करती है कि वर्टिसेस 0 से n-1 तक होंगे, बट हमें ग्राफ में गिवन है कि वर्टिसेस 1 से n तक हैं, फाइन। सो मैंने DSU क्लास को एज इट इज रखा ताकि उसमें कोई इंटरफेयर ना हो, बट अपने को जो आंसर रिटर्न कराना है उस ग्राफ में तो वैल्यूज 1 से स्टार्ट होंगी ना, सो इसलिए मैंने +1 करा है यहाँ पे। So answer of y will be y plus 1, fine. So what we will do is we will simply return this answer, fine. I think this much part is clear. Let us run this code. Okay, so this is giving me a compile time error. So yes, so this is basically not size, this is length, fine. So now I think this should work. So yes, it is accepted. Let us submit it. So yes, it is accepting. So this is how you can solve this problem using DSU, right? So hope you liked the video. Thanks for watching.